Hi, so this video is about your homework from the 23rd of November. So for those who submitted, I appreciate the fact you submitted and your attempt, and it's visible you did your best. Nevertheless, there were some common mistakes which were pretty similar, and I believe it will be more productive to address them here in general channel. Okay, so as you remember, your task was to design a dataset consisting of 10 observations and 100 observations. I will not concentrate on this. I will just show you how to do histogram and how to run and interpret normality test. Okay, so this is inequality dataset. We already used it before. So let's say I want to check whether the variable standing for GDP growth is normally distributed. Oh no, actually I have GDP per capita. So let's stick to GDP per capita. Okay, so if I want to design a histogram, I choose frequency distribution, show data only, and here I have my data. So technically speaking, here it is. Of course, there is no distribution visible. It's just all about the data. So for instance, if you wanna have a nicer graph, you can use the same command, but then increase the number of bins, let's say up to 100. So here you have it. Now it looks definitely more detailed. So additional possible option is to add normal distribution and test against normal distribution. So here we have it, and as you can see, data are definitely not distributed normally. So yeah, so this curve stands for hypothetical normal distribution calculated based on the value of mean and standard deviation using the formula we discussed before. So how it would look like if it would be normal. And this normal distribution was computed, as I mentioned before, based on the value of mean and standard deviation for GDP per capita data. So to make it more formal, we can also use variable normality test, and here you have it. Okay, so as you remember, for all of those tests, including Jark-Barra test and Shapiro-Wilk test, zero hypothesis states that distribution comes from population with normal distribution. In other words, zero hypothesis state that variable is distributed normally. And as we discussed before, if p-value is smaller than 0.05, then we have to reject zero hypothesis. So if p-value is smaller than 0.05, it means that zero hypothesis should be rejected, and we cannot treat this distribution as the normal distribution. So here, in all the cases, p-value is equal to 0. There is one common mistake. So you had this number and you stated that it's bigger than 0.05, but actually p-value stands for probability. So you can already notice that it cannot be like this, it cannot be equal to 5, and actually this number is something very, very small. So you do not have to interpret this, but for instance, we can use Excel for this. Okay, here I have it. Yes. I can choose to format cells. So it's not scientific, it's number. So you see, it's so small that even Excel cannot actually display this number. So I already added 30 digits after the dot, and still I cannot see this value. So basically what I mean is that when you see any variable, any value like this, So here you have 5.16576e minus 0.74. It means that it's something extremely close to 0. So for sure it will be smaller than 0.05. Again, you can double check, pasting it to Excel and changing the format of the number, but it's not required. So as you can see here, we have to reject zero hypothesis, as all of those tests tell us. And we have to reject hypothesis that variable is distributed normally. And we have to admit that variable is not distributed normally. So actually in this case, here I have huge number of observations. I think around 2000. I will not check it at this point. And still variable is not distributed normally. Even though I have enormous degrees of freedom, still it's not enough to reject zero hypothesis. So sometimes you can eliminate some problems by adding more observations and more degrees of freedom, and sometimes you cannot. So I got this result for 2000 observations, and for sure I would get the same result for 100 or 10 observations. Okay, so that was it, and thank you for watching.